Hello everybody, welcome to the Neural Maze. So in today's video we are going to keep working on the project of implementing the 4 agentic patterns from scratch that we started a week ago when we implemented the reflection pattern. So today we're going to move into the second pattern, that is the tool pattern. And before we begin, I'm pretty sure that you're already familiar with this pattern in a practical sense. What I mean by this is that you have probably used in the past tools in LangChain, in Llama Index, or in Crew AI. And the thing is that in today's video, I'm not going to teach you how to use these tools in specific frameworks. I'm just going to teach you how these tools work under the hood. And I think that's really insightful because if we really understand how things work under the hood, I think it's much easier for us to learn how to apply them in the proper way. So as we did in the previous video, we are going to start with a Jupyter notebook that covers all the theory step by step, and then I will move into VSCode, where I will show you all the abstractions and all the classes that I have implemented to make this tool more robust, to try to mimic the structure that all of these frameworks offer at this moment. You know, having like a tool class and a ToolAgent class, very similar to what we did with the reflection pattern, but with the tool pattern. Okay, so let's begin with the theory of the tool pattern. You have this diagram right here that tries to offer a simplified description of what the pattern does or tries to implement under the hood. But basically, let's start by defining what is a tool. And a tool, let's put it in simple terms, it's just a way for the LLM to access the outside world. And what do I mean by this? Remember that LLMs store all the information in their weights. So when you ask an LLM about specific information, that information is going to be retrieved by the weights. But sometimes the information stored in these weights is not enough. And we need a way for the LLM to access the outside world. And that's exactly what a tool does. A tool is just like a Python function that the LLM can access and run and fetch some relevant results using an API or parsing web content or consulting Wolfram Alpha to calculate some difficult integrals. But you get the point. It's a way for the LLM to get outside the information stored in its weights. Okay, so let's start by defining a simple Python function. You have it in here. So this Python function, which I'm a bit ashamed of it because it's too simple, basically gets the current weather. And as you can see, if location is Madrid, it's going to return a temperature of 25. It varies on the unit that you want to put, but given that it's Madrid, it will be unit Celsius, so it's going to return a temperature of 25 degrees Celsius, and otherwise it's going to return 58. So as you can see, don't pay too much attention to this function because it's trivial, but it will help us to illustrate how a tool works. So if we run this, as I was saying, if we run this function with location Madrid and unit Celsius, it's going to return this dictionary, well, this string containing a dictionary with temperature 25 and unit Celsius. So nothing to add about this thing. This is trivial. Okay, so let's proceed. Now the question is, how can we make this function available to an LLM? Because as you already know, LLMs are just NLP systems, and natural language processing systems. So they expect text as input. But we need a way for the LLM to really understand that this is a Python function, and I can call this Python function to retrieve some relevant results. And how can we do that? Okay, so what I propose here is to use this system prompt. So as you can see in this system prompt, we are telling the LLM to behave as a function calling AI model. We are going to provide the function signatures within these XML tags, these tools tags. And you may call one or more functions to assist with the user query. Don't make assumptions about values, blah, blah, blah. Okay, but the important thing is that we are going to pass all the relevant information within these XML tags, and the LLM is going to return the function call inside these XML tags. Okay, this tool underscore tag underscore call. Sorry. You can see here an example of how we expect the LLM to return the tool call. It's going to be something like this. We are going to, the LLM is going to provide a name, the name of the function, and also the arguments that we need to use to retrieve the relevant information with this Python function. And then a list of the available tools. In this case, I'm just using this one, like get current weather, because I needed to hard code everything for this tiny example. But as you will see in the VS Code, we are going to make it automatic. So given a Python function, we are going to retrieve all of this information, all of this function signature. It's going to be retrieved automatically in the VS Code implementation. But yeah, if you checked the information that we are providing for each tool, you can see that we are providing the name of the tool, a description. This is something that we can get from the docstring, by the way. We will see that later. But yeah, like get the current weather in a given location, blah, blah, blah. And then the parameters, where we are putting all the different parameters. And this is really important, the type of these parameters. In this case, both the location and the unit are going to be strings. But suppose that we are passing, I don't know, the month, and we want it to behave like an integer, then we should put that type inside the function signature. Okay, so now that we know how this system prompt works, let's put it into practice. Just a quick reminder, today we are going to use a different LLM than the previous video. In the previous video we were using Llama 3 70 billion, but today we are going to use a slightly different LLM because it's the Llama 3 70 billion tool use. So it's a version of Llama 3 that's been fine-tuned for tool use. And that's exactly what we want to do today, so it made sense to use this LLM. Okay, we defined a constant, system prompt, where we copy and paste the system prompt that I shared with you right in the cell below. And now let's run this cell. We are going to ask the LLM what's the current temperature in Madrid in Celsius. We're going to add the system prompt, and we are also going to add the user message to the history. And yeah, let's run this. Okay, so as you can see, we are having a structure similar to the one we asked for the LLM to return in the system prompt. The LLM is returning the name of the tool, and it's also returning the arguments. Since we ask what's the current temperature in Madrid in Celsius, the arguments is going to be Madrid as the location and Celsius as the unit. Okay, but now this is not usable by the LLM. I mean, we have a string, and inside that string we have this dictionary inside these two XML tags. So we need a way to get rid of the XML tags and also transform this dictionary, this string dictionary, into a proper dictionary using the JSON package, the JSON library. Okay, and that's exactly what this function does. This function will get rid of the tool call, or to be more specific, it will get the code inside the tool call XML tags, and then it will transform that string dictionary into a proper dictionary. So let me show you how it works. But as you can see, when we call this parse tool call string, this method, to the output remember that it's this one here, it's going to return a proper Python dictionary. And now if we run the getCurrentWeather, the function that we defined at the beginning of the notebook, if we run this function with the parameters that we have just parsed, it will return the result. So temperature 25 and unit is going to be Celsius. Okay, without any information about the XML tags. That's something that we want to get rid of. Nice. Okay, so now we have the result. As you can see, it's this Python dictionary right here, but we are not over because we don't want the LLM to respond with this structure. I mean, if I ask the LLM for the current temperature in Madrid, I expect the LLM to respond me something like, the current temperature in Madrid is 25 degrees Celsius, for example, but not something like this, not this dictionary. So the last thing that we need to do is to add this observation, the dictionary in here, to the chat history. Okay, and we are going to add this into the prompt, this observation, the observation text into the prompt, and finally just call the agent. And as you can see, the result is exactly what we expected. So the current temperature in Madrid is 25 degrees Celsius. Okay, so now this is everything for this dynamic or step-by-step way of doing things, but as you might imagine, this is not scalable. I mean, we can't generate this function signature for everything that we are going to build. I mean, we could, but it's not going to be efficient. We need a way for the agent to, given a Python function, being able to extract the function signature. By signature, I mean this type of structure right here, and also to decide between different tools. So instead of doing all of this process, we need the agent to extract all of this logic away from the user and to do it under the hood. And that's exactly what we are going to do right now, the logic that I'm going to show you in VS Code, how to implement all of this the proper way. So let's get into VS Code. Okay, so here we are in VS Code. Let me show you the new modules that I have added to the repository. So if you go to the source Agentic Patterns folder, you will find a new folder, the tool pattern folder. And inside you have three modules, the ToolAgent, the tool, and the utils. Let's begin with the tool, because I think it's the most important topic of today's video, and the ToolAgent at the end of the day is just a way to interact with the tool. Okay, so this module starts by implementing a method that allows you to get the signature out of a Python function. So this is basically the method I'm referring to. It receives as parameter a function, and it will get the schema, and out of the schema also the function signature. And the function signature, it's basically the structure that we defined on the system prompt previously. All right. Next, we have this class right here, tool class, that has three attributes: a name, the function, and the function signature. The function signature, as you might imagine, it's going to be generated by this function right here. And the function, it's basically the function that we want to call. When the LLM decides that it wants to use a specific tool, this function is the Python function that's going to be used under the hood. And then we have this tool decorator that can be used to decorate your Python function and to automatically transform the Python function into a tool object. If you inspect a little bit the implementation of this decorator, first you can see that it generates the function signature out of the get function signature method that we explained before, and then it returns a tool object by defining the name using the function signature, passing the function that you are decorating as the function attribute that the tool expects, and finally getting the function signature from the variable that we defined previously. Because remember that we were getting the function signature using this method, and having these three attributes, we are able to generate a tool. Okay. Now let's move into the tool agent, which, as you can imagine, is an agent that has the capability of using tools. You pass a list of tools and it will select the proper tool, the right tool for the specific question that we are asking, and then it will run the tool to fetch the relevant details that it needs from the outside world, and then returning all this information in a natural language to you. Okay, so things that you are already familiar with. So this tool system prompt is basically the one that we explained earlier on the video. And then the tool agent consists of the following attributes. So we need to generate the Grok client, then the model that, remember that by default we are going to use the Llama 370 billion tool use. And then this is the important part. This is the tricky part of this agent. But we need to define the list of tools that we are going to use for this agent. And then this list of tools are going to be used in the run method. So the run method consists of the following steps. First of all, we expect this user message and we transform the user message into a user prompt using the OpenAI API definition. Then we are going to generate both the tool chat history and the agent chat history. And now we are going to generate the first completion. We are going to make the first call to the Grok model. And what this is going to do, these two blocks of code, is to generate basically the logic that we explained in the notebook. Let me be specific. So it's going to, first of all, return the tool call. Okay, this first call, this tool call string is basically this output. And then the parse tool call string, it's a method that mimics the same logic that we implemented in this function. Okay, so at the end, this tool call is going to be something like this. Okay, so now that we have the tool call information, we can get the tool name from this object, from the tool call. We can also get the tool by using this tool stick, because now that we have the tool name, we have also defined a dictionary that contains a relationship between the tool name and the tool. Okay, then we are going to validate the arguments. So to make sure that if the function expects a string, the LLM is not sending an integer. We want to make sure that the types that the LLM has generated in the tool call and the types expected by the Python function match. Okay? And then we are just going to run the tool with this tool run, and we are passing the arguments that we have just defined on the tool call. Remember that if we go to the tool call, remember that we had this arguments key that contains the arguments and its values to retrieve the proper information. Okay, and finally we are going to append this result to the chat history. And remember that we are adding this by using this observation prompt. Okay, so now the only thing that's missing is to make another call to the LLM in Grok, and we will receive the output. Okay, so now that we understand how all of these classes and abstractions work, I think it's going to be really cool to see everything in action. And that's what we are going to cover next. So everything is inside this section of implementing everything the good way. Of course, you have to understand that this implementation, it's not like the perfect implementation, because I'm not trying to create another framework, and I'm just trying to make something that's well implemented, but at the same time easy to understand. So yeah, just bear in mind that we are not trying to create another agentic framework in this case. Okay, so let's continue. Let's see how the tool decorator works, and instead of using some dummy function, in this case we are going to implement something more, something closer to reality, something closer to the tools that you might be wanting to implement in the future. So in this case, the function that I have implemented is a function that fetches the top N stories from HackerNews. If you don't know what HackerNews is, it's a very famous page where you have different types of stories, and many of them link to some article, another to GitHub repositories, to tweets, to whatever. And it's very, very used by a lot of people. So I thought it would be cool to have this function that allows you to retrieve a top number of these functions, of these stories, sorry. And yeah, to convert this, to transform this function into a tool. Okay, so let me show you first of all that the Python function works properly. So if we run the fetch top HackerNews stories with a top N of 5, it's going to take the top 5 stories. Let's check the first one. So, too much efficiency makes everything worse. And if we go to HackerNews webpage, you will see that, yeah, that this is the first story. So everything seems to be working fine. Now let's transform this Python function into a Python tool. And we are going to do it by using this method that we covered previously. Okay, so now that we have run the tool method, the HN tool is going to be a tool. We can access the name of the tool, and we can access the function signature that, as you can see, contains all the information that we put in the system prompt at the beginning of the video. But right now, the cool thing is that everything has been generated automatically. And yeah, you can see here that has a description, and the description has been retrieved from the doctrine, and we have also the parameters here. In this case, it's a very simple function, so we just need this top N argument, and it's of type integer. So everything seems to be working fine, and now let's move into the tool agent. So the tool agent, to instantiate this tool, we just need a list of tools. In this case, we are only using one tool, the HN tool. And now let's run the agent. And in this case, I wanted to check that everything works properly by doing the following strategy. So first of all, I'm going to ask the agent about something that is not related to HackerNews. So for example, tell me your name. And if everything works properly, we should see, yeah, something not related with the agent, with the tool, sorry. And as you can see, given the output, the agent has not used any kind of tool. And that's the proper way to work, because if the user message is not related to any tool, we don't want the agent to spend time on interacting with tools. But what happens if we ask the same agent about the top 5 HackerNews stories right now? So in this case, we should expect the agent to use the tool. As you can see, I have added some login to make it easier to see. But check this. So the agent is using the tool, the fetch top HackerNews stories. It's using the tool with this call dict. So this is the name and the arguments, the top N with a value of 5. And finally, is generating a result. But remember that we don't want this kind of result. I mean, if I'm asking about the 5 top stories in HackerNews right now, I'm expecting something easier to understand. And that's what we achieve if we print the output. And here we have the 5 top stories in HackerNews. The first one is that the article about too much efficiency makes everything worse that we saw in the HackerNews page. And if we click the URL attached, you can see that everything seems to be working fine. I mean, it's not like the agent redirected us to some broken URLs. I mean, the URLs are real, and it's working as expected. So yeah, this is everything I wanted to teach you about tools. My hope is that now when you start using or keep using tools from LangChain, LlamaIndex, or CrewAI, you have a deeper understanding of how these objects work under the hood. And this is everything for today. I'm working on the next videos of this series, the video about the planning pattern and the video about the multi-agent pattern. I think you are also going to enjoy those ones. But yeah, this is everything for today. I hope you have enjoyed the video. Subscribe to the channel if you haven't, and if you like the content. Click the like button if you have enjoyed this video, and I'll see you in the next video.